Hey guys, what's up? My name is Mohit Kashyap and I'm from SVC College of Engineering. So today we are going to learn about real-time systems in our industry. So let's move on to the next slide. So the first question that comes to our mind is what is a real-time system? So a real-time system is an operating system that guarantees real-time applications a certain capability within a specified deadline. RTOs are designed for critical systems and for devices like microcontrollers that are timing specific. RTOs processing time requirements are measured in milliseconds. So basically, here you can see on my screen, there's a flow chart. So the first one is sensor. So this is an example of a yes example for an air conditioning unit. So a sensor is given to an input controlling unit, then it is given to an input interface, then it is passed to a real-time system. Then from real-time system, it is passed to output interface, then output conditioning unit, then actuator. So there are basically three types of real-time operating systems. The first one being is hard real-time operating system. Second one is soft real-time operating system. Third one is firm real-time operating system. So moving on to our next slide. So let's discuss about the applications of real-time systems. The first one and the most important one being is medical application. So a few examples of medical applications of real-time systems are robots, MRI scanners, radiation therapy equipments, bedside monitors, and computerized axial tomography. Then example for robot used in recovery of displaced radioactive material. Robots have become very popular nowadays and are being used in a wide variety of medical applications. An application that we discuss here is a robot used in retrieving displaced radioactive materials. Radioactive materials such as cobalt and radium are used for treatment of cancer. At times during treatment, the radioactive cobalt gets dislocated and falls down. Since human beings cannot come near a radioactive material as it's like really dangerous for life and health, a robot is used to restore the radioactive material to its proper position. The robot has to sense its environment frequently and based on this information, plan its path. The real-time constraint on the path planning task of robot is that unless it plans the path fast enough after obstacle is detected, it may collide with it. The time constraint involved here are of the order of a few milliseconds, guys. So moving on to our next slide. So our next application is automotive and transportation. A few examples of automotive and transportation applications of real-time systems are automotive engine control systems, road traffic control, air traffic control, high-speed or train control, car navigation systems, and MPFI engine control systems. So to put it in easy words, basically every feature you use in a car or in a vehicle, it is based on real-time systems. So an MPFI system is an automotive engine control system. It is a real-time system that controls the rate of fuel injection and allows the engine to operate at its optimal efficiency. In older models of cars, a device called the carburetor was used to control the fuel injection rate to the e-mechanical engine. It was the responsibility of the carburetor to vary the fuel injection rate depending on the current speed of the vehicle and desired acceleration. In MPFI engines, the precise fuel injection rate at each injection point is determined by a computer. An MPFI system injects fuel into individual cylinders, resulting in better power balance among the cylinders as well as higher output from each one along with faster throttle response. The processor primarily controls the ignition timing and the quantity of fuel to be injected. The latter is achieved by controlling the duration for which the injector valve is open. So, the actions of the processor are determined by the data gleaned from sensors located all over the engine. The sensors constantly monitor the ambient temperature, the engine coolant temperature, exhaust temperature, emission gas contents, engine RPM, vehicle road speed, crankshaft position, camshaft position, etc. So, an MPFI system not only makes a vehicle more fuel efficient, it also minimizes the population by reducing partial combustion. So, moving on to our next slide. Another one such application of real-time systems is internet and multimedia applications. So important use of real-time systems in multimedia and internet applications include video conferencing and multimedia multicast, internet routers and switches. Example 9, video conferencing. In a video conferencing application, video and audio signals are generated by cameras and microphones respectively. The data are sampled at a certain pre-specified frame rate. These are then compressed and sent as packets to receiver over a network. At the receiver end, packets are ordered, decompressed, and then played. The time constant at the receiver end is that the receiver must process and play the received frames at a predetermined constant rate. Thus, if 30 frames are to be shown every minute, once a frame playout is complete, the next frame must be played within 2 seconds. So moving on to our next slide. Real-time systems are designed to process data as soon as it is generated and provide immediate feedback. However, building such systems comes with its own set of challenges. Here are some set of common challenges faced in real-time systems. The first constraint is cost. See, to build a real-time systems, it's really expensive, and especially when they require specialized hardware or software. Second one being is the data quality. Real-time systems rely on accurate and reliable data to function properly. Poor data quality can lead to incorrect results and decisions. Complexity. Real-time systems can be complex and difficult to design, implement, and test. They often require specialized skills and expertise. Scalability. Real-time systems must be able to handle large volume of data and users without sacrificing performance or reliability. Security. Real-time systems must be secure to protect sensitive data from unauthorized access and modification. To overcome these challenges, organizations must invest in the right technology infrastructure. They must also have a clear understanding of the business's requirements and goals. So, this is all for today, guys. So, thanks for watching my video. See you again. Have fun. Merry Christmas. Bye bye.